So let's go ahead and work this problem on heat conduction. And so here's our heat conduction equation. And we're asked to compare the heat conduction of this window, these windows that are on this wall, to the heat conducted through the wall. So here's our expression for heat conduction. So we're interested in, then, the heat conduction from the window, and I'll just call this glass, or G, divided by the rate of heat conduction through the wall. Okay? So, here's our expression. Then in the numerator we have K for the glass times the area of the glass divided by the thickness of the glass times T2 minus T1. So T2 would be the warmer temperature, so that's the inside temperature, minus T1, which would be the outside temperature. Okay? And that's divided by the heat transfer through the wall. So this would be K of the wall, area of the wall, divided by thickness of the wall, times the temperature difference again, T inside minus T outside. Okay? So we have a situation then where the temperature difference is the same in both the numerator and the denominator. So we can just go ahead and cross that out. It cancels out. Okay? Okay, so we have these three quantities for each of the glass and the wall that come into play here. And I'm going to go ahead and rewrite this slightly. So let me go ahead and erase that here. And so what we'll have the ratio of the K's, the ratio of the areas, and the ratios of the wall. And so let me rewrite this slightly. Now the temperatures, remember, cancel out. So what you end up with is K of glass divided by K of the wall times area of the glass divided by area of the wall times thickness of the wall divided by thickness of the glass. Okay? So we had this in the numerator, that times that divided by that, and then denominator we had that times that divided by this. And so I've just rewritten this in a slightly simpler form. So we can then plug in the values that were given for these various things. We're told that K of the glass is 0.84, whereas for the wall it's 0.084. So just considering the K's here, we have 10 times greater K for the glass than the wall. So that's going to lead to 10 times greater heat transfer if this were the only thing that was different amongst the glass and the wall. But we have different areas and different thicknesses. So the areas, the glass area is 2 square meters. The wall area is 10 square meters. And then the thickness of the wall is 13 centimeters. The thickness of the glass is only 0.75 centimeters. So the glass has two things going for it that make it transfer heat much more effectively. It has a larger value of the conductivity, 10 times larger, and the thickness is considerably thinner for the glass. So that means it's going to transfer heat a lot more effectively. The areas, well, the wall has a larger area on the wall than the glass, so that's going to kind of work in the wall's favor for transmitting heat. So when you multiply all this stuff out, you get the number, it's about, to two digits, to two significant figures, it's 35. Okay? So what that's saying then is that 35 times more heat will be transferred through the glass than through the wall per second. So the lesson here is you really don't want to have too many windows in your house. It's nice to have lots of windows, but they transfer heat to the outside a lot more rapidly than the walls do. So there are ways to get around this, building thicker glass windows, double pane windows, things like that. But this is a pretty good example showing why, showing how glass is just a much better transmitter of heat than the wall is. About 35 times better in this particular example.